Hello, my brilliant students. Welcome back to our physics prep series, designed to get you ready for your WAEC, JAMB, and NECO exams. Today, we're diving into a topic that is literally all around you. I'm talking about simple machines. This is one of those topics you absolutely have to know for your exams. So let's jump right in. So let's start with a big question, one that people have been trying to answer for thousands of years. How do we make work easier? I mean, how is it possible to lift a really heavy car with just a small jack or split a massive log with a single axe? Well, the answer is what this whole session is about. You guessed it. The answer is simple machines. These are the basic tools that act like force multipliers. They basically give us superpowers. Think of them like the Lego bricks of engineering. If you understand these basic blocks, you can understand how almost anything works, from a simple wheelbarrow to a massive construction crane. And believe me, examiners love when you can make that connection. Okay, so here's our game plan. First, we'll see exactly what the syllabus says you need to know. Then we'll get into the nitty-gritty, the core concepts and all the formulas. After that, we'll meet the whole family of simple machines. And the best part, we're going to solve actual past exam questions together. Then we'll wrap up with a handy formula sheet and some killer exam tips. You ready? Let's go. So, section 1. Why should we even care about this topic? Well, because WAEC, JAMB, and NECO care. Everything we're about to cover is pulled straight from your official syllabus. So this is 100% need-to-know stuff. So here's what the syllabus demands. You need to know the definition, of course. You've got to master the key terms: load, effort, MA, VR, and efficiency. They also want you to know how to derive the efficiency formula. And of course, you need to know all the different types of machines and be able to crush any calculations they throw at you. We are going to nail every single one of these points today. All right, let's get into the language of machines. These next few concepts are the absolute foundation for everything else. So pay close attention. Once you get these, the rest is easy. First up, we've got the load, which we represent with a capital L. This is just the thing you are trying to move. It's the problem you are trying to solve. It could be a heavy block of concrete, a bag of cement, anything. It's the resistance you are working against. And on the other side, we have the effort, capital E. This is your push, your pull, your turn. The whole point of a simple machine is to use a small, manageable effort to overcome a much bigger load. Now, this is where the magic really happens. Mechanical advantage, or MA. This number tells you exactly how much the machine is multiplying your force. It's simply the load divided by the effort. So if your MA is 10, it means the machine is making you 10 times stronger. It's an awesome measure of the machine's power. But there's always a trade-off, right? You don't get that amazing strength for free. You pay for it with distance. And that's what the velocity ratio, or VR, tells us. It's the ratio of how far your hands move, the effort distance, to how far the load actually moves. So you might have to pull a lot of rope just to lift a box a little bit. Finally, we have efficiency. You see, in a perfect world, all the work you put in would be used to move the load. But we live in the real world, and in the real world, we have friction. Friction is like a little thief that steals some of your energy. Efficiency tells us what percentage of work actually gets the job done. It's the MA divided by the VR turned into a percentage. And a key thing to remember, no machine is ever 100% efficient. Okay, this is a classic exam question, so let's break it down. Imagine a perfect machine with zero friction. The work you put in, that's effort times effort distance, would perfectly equal the work you get out, load times load distance. If you rearrange that formula, you find that L over E equals DE over DL, which means MA equals VR. But in reality, friction means the output work is always a little less than the input work. And that's what efficiency is, the ratio of useful work out to total work in, which after some simplification just becomes MA over VR times 100. Make sure you understand that logic. Fantastic. Now that we're speaking the language, let's meet the whole family. There are 6 main types of simple machines you've got to know for your exams. So let's start with 2 of the most common ones. A lever is just any rigid bar that pivots around a fixed point, called a fulcrum. You know, like a seesaw or using a crowbar to lift something heavy. Then you've got the pulley. That's just a wheel with a groove for a rope. You see them on flagpoles, in elevators, and at construction sites lifting heavy materials. Next up, the inclined plane. This is just a fancy term for a ramp. It makes it way easier to move something heavy upwards, right? Like pushing a wheelchair up the ramp instead of trying to lift it up the stairs. And then there's the wheel and axle. Think about a car's steering wheel or even a doorknob. You apply a small force to the big wheel and it creates a much stronger turning force on the small axle. And our final two, the screw is really just an inclined plane that's been wrapped around a cylinder. The lid on a jar is a perfect example. And lastly, the wedge. A wedge is basically two inclined planes put together, back to back, to make a sharp edge. Its job is to split things apart. Think of a knife, an axe, or even your front teeth. Okay, enough talk. Let's crunch some numbers with a classic lever problem. First, the velocity ratio. For a lever, that's just the effort arm divided by the load arm. So 2 divided by 0.5 gives us a VR of 4. Simple. Next, let's get the MA. That's always load divided by effort. So 400 divided by 120 gives us an MA of 3.33. See? Now, to find the efficiency, we just use our formula. MA divided by VR times 100. So that's 3.33 divided by 4 times 100, which gives us 83.3%. You see the pattern? It's always about the relationship between these 3 or 4 key things. All right, this is the moment you've been waiting for. We've learned the theory. Now let's apply it to real past exam questions. This is how you really prepare to win. Let's do it. Okay, here is a WAEC question. Now, don't be scared by all the words. We'll break it down. First, the velocity ratio of a screw jack. The formula is 2 times pi times the length of the handle, all divided by the pitch. Just plug in the numbers and you get a VR of about 714.3. Now for the MA. We know the efficiency is 80%, right? So we just rearrange the efficiency formula. MA is efficiency times VR. So that's 0.80 times our big VR, which gives us an MA of about 571.4. Next, the effort. First, we need the load, which is mass times gravity. 8,000 times 10, that's 80,000 newtons. Now, we just divide that huge load by our MA, and we find the effort needed is only about 140 newtons. Amazing, right? It's just following the steps. Now, let's look at a JAMB question. These are usually faster. We have the VR, efficiency, and the load. We need the effort. The quickest way is to find the MA first. So MA equals efficiency times VR. That's 0.75 times 5, which gives us an MA of 3.75. Now we know MA is load divided by effort. So to find the effort, we just do load divided by MA. That's 150 divided by 3.75, which gives us our answer, 40 newtons. Done. That's how fast you need to be for JAMB. And let's do a typical NECO problem. Here, they want us to find the efficiency. They've given us everything else. So what's the first step? Right, we find the MA. MA is load over effort. So 200 divided by 60 gives us 3.33. Now we have the MA and the VR. So to get the efficiency, we just divide them. MA over VR times 100. That's 3.33 divided by 4 times 100, which gives us 83.3%. You see the pattern? It's always about the relationship between these 3 or 4 key things. Whew, we've covered a ton of ground. Now let's boil it all down into a super simple, easy to revise summary. Get ready to take a screenshot of this next slide. It's your ultimate cheat sheet. And here it is. Everything you need in one single table. The formula for MA, VR, efficiency, and the specific ones for levers and inclined planes. Commit these to memory and you'll be absolutely golden for any calculation question. Okay, and before we finish, my top 5 exam tips. 1. Always include your units. Newtons, meters, whatever. Don't lose easy marks. 2.
If you draw a diagram, label it. It makes you look smart and gets you points. 3. Assume gravity G is 10 unless the question tells you something else. 4. Show you're working. Even if your final answer is wrong, you can get marks for your method. And 5. In a theory paper, I always tell my students to do the math questions first while your brain is fresh. Trust me on that. And that is a wrap on simple machines. I'm confident you can handle any question they throw at you now. If you found this explainer helpful, do me a huge favor. Please like this video, share it with your classmates and friends who are also getting ready, and make sure you subscribe to the channel right now so you don't miss our next topic. And for thousands of 3 practice questions, visit examkp.com. Let's go smash these exams.